class right now. I'm taking the one that not Monday, Tuesday.
All right, we'll go ahead and start, and it's recording. So, all right. So, hope you had a good spring. Welcome to CSE 223. So, this is a continuation of 224, 222, third and final course in the sequence. So, the title of this course is something like Advanced Data Structures in Java or something to that effect. But that's basically what we're doing here. We're continuing the development of data structures that we started in 222, and we're shifting over to an object-oriented domain, which is Java. So we're pretty much done with C for this course. We're not really doing shell scripting, but everything that we've done in C and in Unix and commands and greps and all that stuff will help us in here, because it's underpinning everything that we do. Let me do a really quick run through on some of the administrative stuff. And what I want to get through today is administrative details, and I want to talk a little bit about, well, I want to mention the ODP and get you started on that, and I want to talk about labs because there's a lab component to this course, and you'll be doing 4 or 5 labs. But let me run through some of these details first. So my door has my office hours along with the usual engrcs.com/schedule. You can find my hours there, but it's kind of the same as last time. The textbook is online, so it's an intro to programming using Java. It's an open source book. There's nothing magic about that book, though. We're not going to be assigning homework from that book or referring to specific examples from that text. It's just an open, freely available textbook I found that does a pretty good job of covering the things that we're going to be going over for the most part in this course. But Java has been around for decades, and there's tons of resources available, and there's some links to this sort of official documentation for the classes on Canvas. So lots of options for finding information. One thing to know down the road, we're going to be working in Eclipse, not for our first programming assignment, not for the first labs, but eventually we're going to be working in Eclipse. So you'd like to go ahead, if you're going to run this on your own equipment, and install Eclipse sooner rather than later. Okay? It's usually a pretty painless install, but if you try to do it the night before you need it for an assignment, and you run into some hiccups, right? So try to do that early, and Friday we can take class time and work on installation issues and so on if you like. So eclipse.org is the main site for Eclipse. Course outcomes, I'll let you read on your own. Grading, everyone cares about, so here's the breakdown for grades. So probably 5 programming assignments, total of 20% of your grade. A smattering of one-day programs, 10% of your grade. Labs will be 10%, and there's going to be 4 or 5 labs. Service learning project is 10%, midterm 20, final 30. Pretty straightforward. The rest of this is kind of boilerplate stuff, which I encourage you to read, but assuming that you were taking courses here last quarter, you've already seen this, and we've talked about it. But if you have any questions about it, come and talk to me or raise your hand. So, as usual, there's additional course policies which in some ways are tuned to this particular section and this particular offering of the course. So my office is the same, SPG 115, that's the link to the online schedule. This lists my hours along with Izad and Carol and Tina. So look for my name if you want to see when I'm available. Assuming proficiency in programming at this point, okay? Assignment statements, conditionals, looping, all of these things should not be mysterious to you, okay? Everything that we've done in 224, 222 should be rock solid at this point, okay? Because we're going to be using these things, but we're going to be using them to learn more about data structures and to work with Java. Not assuming any background in Java, though. We're starting from scratch today. No previous experience with Java necessary. Okay, there will be a lab component, so we have these oversized USB devices. You plug them into a USB port, they boot up as a Linux machine, okay? It's a little Raspberry Pi Zero inside. And the cool thing about this is there's places on the side here where you can put wires, and these are general purpose I/O ports and other kinds of ports. And from Java code, we can read or write to these locations. So you can do things like run some wires from here to a breadboard, put in an LED and make the LED blink with a Java program, or connect a button and read whether the button is pressed or not from a Java program. So we're going to be doing some labs that are very, very simple in terms of wiring up a breadboard. It's going to be a switch, an LED, a few wires, things like that. Nothing complex like in 250 or 270, but we're going to be writing Java code to work with physical things. So it's a different component to the course. And we're going to work in groups of 2 or 3 people. Now, we have 19 of these units available. We lost 2 of them last year. So they're in the collaboratorium. There's a shelf towards the right back corner. It's labeled CSE 222, 23, 24. It's a cabinet. If you look in there, you'll see 19 little boxes. They're plastic boxes with one of these, a mini breadboard, some wires, and LED and switches. And your first lab will be due on Friday. Okay, so one of the first things you want to do today is you want to find out who you want to work with. Put yourself in groups of 2 or 3 people, and there's a sign-up sheet on the door of that cabinet. So pick a group number and put your names there, full names please, and self-divide like that. 19 boxes, ballpark 40 people in the course, right? So most groups will be able to have 2. Might be a few with 3, I know. Somewhere there's 40 people. Let's talk about emails. So I want to avoid one-on-one emails about the course material itself as much as possible. If you're having a particular issue, I can't come to class next Wednesday because of such and such, right? Shoot me an email or come and talk to me. If you really feel like you're struggling with something that's very particular to you, right? I have some kind of mental block about try-catch statements. I've written it, a bunch of times. I'm just not getting it. Can you explain it differently, right? That's good for an email. But more general questions, right? When is this lab due? What should we do if we can't find a piece in our lab box? Programming assignment 1 doesn't say how we should test it. Do we have to include a main program? Things like that. I'd like you to start using the discussion area of Canvas. Okay? Go into discussions and just say start a new discussion, or if it's something that's already being talked about, just add on to the end of the discussion so that everybody can see it and I can respond, and the response will go to everybody who wants to read it. Okay, so before you send an email, think about that. Is this something that is really just between me and the instructor, or is this a more general question? If it's a question that you feel comfortable putting out there, right, for the whole class, go ahead and do that. And a lot of times you'll find that other people in the class will respond before I get to it, and sometimes they have a better response than I do. But don't post code, right? Here's my finished program, it works perfectly, but I don't know how to add a comment here, right? Don't post that. All right, exam, same as before, closed book, 4 pages of double-sided notes. That's for the midterm and the final. Programming assignments, okay, even more so in this course than before. Let me stress this. You gotta write your own code. You gotta avoid looking at other code, okay? There's code in the textbook. There's code that we'll go through in class. There's code you've written. There's code that I'll post online where you can see it. Those are fine. But avoid Googling linked list Java, right? If you're trying to make a linked list in Java. Once you see a linked list implemented in Java, you can't unsee it. And your chance to learn how to implement that yourself is gone, right? So really, really, really try to avoid looking up code online, textbooks, other people, things like that. If you really feel like you need to do that and you're not going to be able to do anything otherwise, let me know, okay? That's a good email question. And say, hey, I understand linked lists, I understand Java, I'm not sure how to put them together, okay? and I'll try to help you down that path without just giving you a linked list in Java. All right, no late work, except programming assignments. You can turn them in 24 hours late, 25% deduction. Okay, that's from the first minute on to 24 hours. So don't think of this as an opportunity to get more time for a programming assignment. This is a something goes wrong, your alarm clock doesn't work and you oversleep past the deadline, or your network goes down, or something happens and you plan to get it in on time, but you can't do it, right? So turn it in as soon as you can after that, right? Within 24 hours, you get 25% off, but it's better than a 0. Okay, but it's really not like, how many points will I get if I get this thing working in the next 24 hours? That's not really the goal. Okay, think of the deadlines as rigid, but if something goes wrong, right, and you've spent 2 weeks on this, I want you to be able to get some points for it. So there's that 1 24-hour grace period. Everything else, no deadlines, ODPs close automatically. And the rest of this is the same as I've said every class that you've had with me pretty much. So trying to come to class and focus in class and pay attention in class and think about the concepts while you're here and so on. Document your code, put comments in, etc., etc. So no big surprises there. All right, and any questions coming up anywhere along the way, obviously, just go ahead.
Are you going to record this quarter too?
Yes, so we're recording right now, assuming it works, and I'll post these on Canvas, and I'll put a link. I'll post them on YouTube. I'll put a link on Canvas today once I get the first video up.
This is very useful.
Cool, that's good to know.
It helps a lot.
And I like people to come to class, but if something happens and you can't be here for one class, right, it's
It was like when we were working on projects, I'd be like, I remember he said something, and then I could go back and see like everything.
Okay, cool. All right. Well, let's talk about labs. And to me, the labs are a fun aspect of this.
Yeah,
So
I was looking at it, it seemed fun.
yeah. So these are homemade, okay? So you get what you pay for, right? There's a Raspberry Pi Zero inside. There's a USB adapter, so it gets its power from the USB port, and you plug it in and it boots up, and it's a Linux system. So Lab 1 is really, it's not really any Java, it's just a warm-up. It's getting used to this thing, it's getting logged onto it, and it's learning how to move around in this environment. And I want you to think of these as, within your group, your own sort of personal Unix environment, okay? You're welcome to do anything software-wise that you choose to with these, but I'm gonna ask you not to take the cover off, okay? Don't pull out the flash card and add new things to it. Don't throw in a Wi-Fi adapter, stuff like that. You can do those things physically, right? It's easy to do, but there's 2 reasons I want you to avoid that. One, a lot of times once you take the cover off, things get damaged, okay? When I took these apart to get them ready for this quarter, a lot of the wires have been crunched because people put the covers on, but they didn't get the wires out of the way, and things got crunched. A lot of the flash drives got corrupted last year, so I threw all of them out and totally put in new flash drives. But 2, I want you to get into the mindset of working with a sort of pared down device like this. Now we're going to be writing a lot of our code in Eclipse. It's a huge development environment. It has, automatic syntax checking. It does color coding of your code. It will do code completion for you. If you have an error in your program, it'll put a squiggly line under it, and you can just hover on that and hit Alt-Enter, and it'll fix your code for you. It'll write documentation for you, okay? It really does everything but eat. And this is the opposite end of the spectrum in some way, right? It's command line based. You're going to have to use VI. I set up VI to look like it used to look on CTEC though, so I gave you your arrow keys at least. But you're really going to have to sort of write code from the ground up. And I want you to have that experience because that's an experience that you're likely to encounter as you move on from Clark and from your bachelor's degree and so on. So embrace that if you can instead of trying to fight against it. It'll be a more interesting experience. So find your working groups, go into a collaboratorium, sign up on that sheet, and there's a box in there. Okay, so guidelines. You want to make sure you're using the same unit each time that you work with this. This is going to be just for you and your group for the entire quarter. And that's important because you're going to be writing code and putting code on here, and you probably want access to the previous code that you wrote for earlier labs. Okay, or if you're making tools, compiling your code takes, a bit of typing. You might want to make a little one-line script or an alias so that you can just compile and run your Java code. And you don't want to have somebody else take your device and delete that and so on. So stick to using your parts kit and your unit. I'm going to ask that you don't take these out of the collaboratorium. Okay. The reason for that is because last year, as I said, 3 of them walked actually. And that's just, it's a pain down the road for everyone. I also want to ask that you coordinate with your lab partners as much as reasonable. There's a lot of times where people came to me and they said, hey, I'm trying to do my lab, I don't know where the box is. And I'm like, have you asked your lab partner? Well, I don't actually know who they are. Okay, so avoid that. So coordinate, right? If you're going to make major changes like changing the password on your login, for example, right? Coordinate with the other people in your group. Okay, so common sense. The other thing is make sure you shut these things down correctly. Okay, so when you're done, you're going to log in. You're going to be sitting at a command shell prompt. When you're done using it, don't just pull it out. Okay, because it's even more sensitive than a flash drive. Things that are written to the hard drive in here may not actually be written out. So you want to shut it down, and the correct way to shut it down is sudo shutdown-h now. Okay, that's a correct way. And do that and wait a few seconds. It should eventually give you a message that says power down, and then you can pop it out. If you don't see a message after like a minute, just pull it out anyway. But that synchronizes the file system and so on and so forth. All right, so depending on what your environment is, there's different ways that you're going to actually use this. Linux, Windows, or OS X. So Windows, which is probably the most popular option, you can talk to this through PuTTY. Okay, so pop it into a serial port and either go to Device Manager and look at your ports to see what the device is, or use the command mode, and you'll see probably COM4 is the device, but go into a command prompt, right? So Windows key, search for command and run that, right? Or just run CMD. So use the mode command, it'll show you all your ports. Plug this in, use the mode command, see what the new port is. Okay, if it's COM4, open up PuTTY, and here's what you want to do. Set this to serial, put in the name of the serial line, COM4, set the speed to 11.5200, and you can save it as a profile if you want, and open it up, and hit the return key a few times. And if you're lucky, you'll start seeing a whole bunch of outputs spewing, okay, the boot up messages. So it's just like running Linux on a desktop system. And eventually it'll bring you to a login prompt. Okay, and I think I put the login in here. Yeah, so your username is Pi, the password is Raspberry. Okay, and that's standard for all Raspberry Pis. And like I say, if you want to change it, you can do that. If you want to create your own account, you can do that also. But if you change it and you forget what the password is, right, I might just reinitialize it for you. Okay, so for Windows, use that. For Linux, your best option is Minicom. Although if you have your own favorite serial device screen or whatever, you're welcome to use that. But I put instructions in here for Minicom, and we're going to use Linux here in a minute. So I'll show it to you up here. But sudo is how you say I want to run this with root privileges. So sudo minicom, and usually when you plug this in, it'll be called /dev/tty_usb0. If it doesn't find it there, look in the /dev directory and see what it's called. And then you need to put in this cryptic line to basically turn off hardware flow control. Okay, so Control A, Z, P, E, Enter will let you set the baud rate, which is kind of optional. But then Control A, Z, O, scroll down to serial port, hit F to turn off hardware flow control. That's the important part. If you don't do that, it doesn't talk. And then hit Escape twice to go back to a regular terminal session. OS X I have not tried, but I've had students before who posted these instructions and said that this gets you on the air if you have a Mac. So you can try that. And I tried it this morning, and it does work from the PCs in the Collaboratorium, so you're good to go with that. All right, so let me go ahead and just pop this in. So I'm going to unplug my mouse. So if I try to do this right now, shouldn't have worked at all. Oh, yeah. All right, well, I'll just plug it in. I kind of set this up to do some stuff automatically. So we'll give it a minute. Okay. All right. So there's my Unix system. Okay, and it's actually running on this little USB dongle. So it's a full Linux system. It's got the important commands built in, and so on. And when you want to shut it down, sudo shutdown-h now. H means halt, now is when I want it to shut down, and eventually it says power down, and then you can just pull it out. And Control AQ will get you out eventually.
So if we don't do that, files won't sync, you said?
Yeah, it's possible you could do some corruption to effectively the hard drive, the flash card. You can also use the sync command, which should take care of that. All right, so what are you doing for Lab 1? Go through all of that, get your software set up on your machine, Windows, Linux, Mac, whichever, so that you can actually connect to this thing and get a login prompt. Okay, go ahead and log in and do these different steps. So first step, use the df command, see how much space you have in the file system, and you'll see a number of different file systems, but it's all one physical device, it's all one flash card. And it's usually either an 8 gig or a 16 gig flash drive. So see how much space is in use, how much is available, and you have to look at the units, okay, whether it's K or M or G. If you only have a few gigabytes of space available, if it says you've got 2 gig free or 3 gig free, chances are you're not using the entire file system. So there's a command called raspi-config, which you run with a sudo command, and that gives you a bunch of options. So find the option that says expand file system. It will ask if you want to expand the file system, say yes. It'll say, do you want to reboot, say yes. And then when it comes back up, do a df command again, and you should see more space available, either close to 8 or close to 16. Okay, so that's your second step. And what you're doing in your lab report is you're just reporting on these things that you've done. Okay, so step 3, go back into the raspi-config command and look at some of the other options that are available. There's a whole page of options, and there's one option which says advanced options, and there's a bunch of advanced options. So just look around at those. Give them a try, or do some research, or speculate, or whatever, okay? The goal here is just to sort of get familiar with this Linux environment. Question 4, see what version of Java is installed on the system. Question 5, see how much memory is available on the system. Question 6, get an idea approximately how many tasks are currently running on your system. Okay, it's going to be more than just you. It's going to be a bunch of things supporting Linux itself. 7, go to the boot/expert directory and see what's in there, and 8, go into the packages directory and see what's in there. Okay, come into this with the mindset of exploration, right? It's not a checklist of I did this, I did this, I did this. I mean, you can do that, and I'll give you credit for it. But these are suggestions for how to explore what's going on in here, right? And it's a fairly typical Linux environment. So if you've never installed Linux on your own machine and played around with it, right, this is a chance to do this. So set aside some time and have some fun and see what's going on in here. Run the cowsay command and put the output of that in your lab report, and then finally shut down the system. All right, so write up, doesn't have to be super fancy. Okay, I don't need, list of materials, procedures, etc., right? But a lab report, okay? Not a piece of paper with some scratchings on it, but, at least your name of your partners, the course, the date, lab 1, a sentence or two about the purpose, and then mostly just write about the procedure, right? So step 1, well, tell me about logging in, right? What system you were using, what kind of operating system. Did it work? Did you have to make some changes? Did you have to install some mysterious driver from a Russian website? Whatever. And then, we ran the df command. This was how much space we had. This was not as much as we expected, so we went ahead and ran raspi config. And just tell me what you experienced with all of this, what you did, and so on. Write that up as a PDF, submit it to Canvas by Friday. That's your first lab. You're good to go. Okay. The following labs will actually start hooking these things up to things through a breadboard, and we'll be making lights flash and all kinds of good things like that. So questions about that?
And are the labs going to be weekly? Yeah.
No. So every other week, 5 labs total,
Okay.
and they'll alternate with programming assignments. So labs will be due Friday, programming assignments will be due Friday, except for the last one, which is due on a Monday, I believe. Last programming assignment.
So are labs going to be more like manipulating things, and then programming assignments is going to be like?
Programming assignments will be pure, right? Let's write a program that plays 20 questions, right? Or implements a tic-tac-toe game, or does a heap sort or something like that. The labs will be, well, I'll show you an example. So lab 2, we're blinking an LED, right? And I give you some snippets of code that will help in writing that, but you're basically going to write some Java code that will drive one of these output ports high and low alternately. And you compile it up, and you run it, and I tell you which pins to connect to, pins 14 and 16, and there's a little 1 and 2 here to tell you which holes are which. And you connect those pins to an LED, you run your code like this, and it should blink, right? And then there's another one where you control the time in between them and so on. And all these labs, other than the first one, there's a sign-off sheet here. So whoever's in the lab at the time, you can put your group number, members, date, and this just tells the person signing off what the experiments are supposed to do. So experiment 1, LED blinks on and off in response to user input. You demonstrate that, they sign it, and so on. And that's your signature sheet you include in your lab report. All right, do you have a question in the back, someone? Yeah.
Everything is all the programming science are written in ellipse. We're going to
No, the first one is not.
Okay.
Okay, programs 2 through 5 will be Eclipse. First one we're just going to do straight on the command line, kind of like the first few ODPs. And the Java code you write on here is not going to be Eclipse, okay? There's no Eclipse on here, there's no graphical system on here, it's all command line based. And again, I'd like you to try to embrace that, okay? Programming assignment 1, ODPs, will be working from the command line, so you'll know how to do it. I've had people who go into, their favorite IDE, IntelliJ or whatever, and write all the code there with the color highlighting and the syntax checking and everything. And then they copy and paste it into a file on here and they run it. That works, okay, and I'm not going to dock you points for that, but it really sort of takes away a big part of what you're trying to learn here. Okay, and in particular when you're doing the exams, right, you don't have all those features available to you. You've really got effectively command line access, pencil and paper. So it's good practice too. All right, let's hop onto the server. So your first ODP is ODP 300. It's a hello world. So here's the kind of thing that you would write. So this is a class called myMain, and it's going to print out hello world exclamation mark, and that's it. Okay, and we'll be talking about what all this stuff means in later today and tomorrow and in coming days. But you can take this as, right, this will do what you want it to do. So you put this in a file called mymain.java, and unlike C, file names are pretty critical in Java. So if I'm creating, in this case, it's something called a class, okay, it's like a structure. If I'm creating a class called mymain, I really need to put it in a file named mymain.java. Okay, I can't throw it in a different file because the compiler is going to complain and say, hey, it's called mymain, but it's in a file called blah, right? So you want to put it in a file called mymain.java. And we do compile C in some sense, and it's the Java C command that we use. So take this stuff, throw it in a file called mymain, compile it by saying java c mymain.java. And then you can run it yourself in your current directory by just saying java mymain. And if you do that, it should print out hello world. Okay. Assessment in this class is a little different from last class. I'm always going to give you a test bed, but you're not going to link to that test bed in the way that we did in 222. Okay. If you want to assess, what you're going to do is you're going to say assess /temp /mymain -300 space, and then the name of your .java file. Okay, but you have to have already compiled it. So the goal here is to navigate these peculiarities, right, and get it to say hello world. So write your program in a mymain.java, compile it like this, and then from that directory where you compiled it, type in this assess statement. And go ahead and use the G command for grading, and you should get 10 out of 10. When you do, you're good to go.
Does compiling Java C overwrite your mymain in this case?
No, it creates basically an object module.
Okay.
And we'll demystify that in the coming comments.
I think the .java file and create a .calls file.
Yeah, exactly. So here's what's going on basically. You have a file .java. Okay, that's source code. You compile that with the java c command, and it will give you a file.class. Okay, that's effectively object code. It's actually called byte code. And this gets run through the Java command, and that executes it. Okay, so questions on the ODP, because we're starting to talk about something else now, but questions on the ODP? Right, the instructions basically tell you how to do it. Try to do that like after this class. It's not due till Wednesday. It's a 2-day program. So there's opportunity there to ask questions and try multiple times.
Okay, this is on the,
This is on the Linux server.
okay.
Yeah, so all of this is on the Linux server. Programming assignment 1 will be on the Linux server.
Will all the ODPs be on the Linux server, or will
Yes.
they also transition to a
They'll all be on the Linux server.
cloud?
If you wanted, you could write a quick simple code to the server. and
Yeah.
not-
Same thing with the Mac, right?
Wow. Okay, so let's back up and let's talk a little bit about Java in general. So who here has worked in Java before? So what is Java? How would you describe it to someone who knows C and knows computer science but doesn't know anything about Java? What would be one sentence you would use to describe Java? Okay, go ahead.
It's object oriented.
It's object oriented. Okay, that's a big distinction from what we've been doing. It's object oriented. What else?
It streamlines ideas from C into easier to understand concepts in some cases.
Oh, interesting.
So is it like based off of C, or is it something completely different?
Well,
It wouldn't be like higher level than C.
Yeah.
It's like a higher level language.
let's say like C but better.
Yeah.
This is an opinion, of
It
course.
uses similar
I mean, C's
words.
still
Is it an opinion, or is that actually a fact?
Oh, there are no facts, right? Yeah.
It's
We're doing things like we did in 222. We're creating structures, right? Which means we're allocating memory on the fly, but we never use a free statement, right? You almost can't get memory leaks because there's no way to effectively release memory. It gets collected when it's no longer in use, so there's something called a garbage collector that runs in the background and cleans up, reclaims unused memory.
C without the dirty work.
C without the dirty work. That's a lot of what this like C but better is getting at, right? So yeah, the syntax looks a lot like C, although more and more languages look a lot like C, right? But better. None of these goofy arrays of characters with a null terminator for a string. There's an actual string in Java, right? Arrays come with a length component that tells us how many things are in the array or how big the array is. Anything else?
It's portable.
It's portable. And in some sense, C is portable, right? Because C is well defined. But if you compile a C program, or you compile 1,000 C programs and create an executable on my laptop, and then I copy that executable to a Raspberry Pi, it will not run, right? Because when you compile C, what do? You get a bunch of ones and zeros, and it's the ones and zeros that this thing's CPU understands. This thing has a different CPU. It has an ARM processor, totally different architecture from an Intel. And it doesn't understand the same ones and zeros. But when you compile your Java code, you get a standardized set of ones and zeros, basically. And it's not the ones and zeros that an Intel processor understands or an ARM processor understands. It's the one and zeros that are understood by something called the JVM. That's the Java Virtual Machine. And it's a make-believe piece of hardware. It's a pretend CPU that actually runs on top of an Intel processor, an ARM processor, or something else. And so I can take the compiled version of a Java program, and I can run it on any system that implements a JVM. So we get that sense of portability. We don't have to recompile and relink or all of that stuff we do in C to run our stuff on another machine. We just need to know this other machine implements the same Java virtual machine, the same JVM, and it'll eat the ones and zeros directly.
So I guess universal might be a better
Yeah, in
term.
some sense universal.
Yeah, that makes sense. Instead of having a compiler, it has a program.
Yeah. Which means that Java is actually interpreted, just like MATLAB and shell scripts and things like that. It's not compiled down to the bare metal. Okay, it's compiled down to some intermediate form, this bytecode, and then there's a program that interprets this bytecode. So it's interpreted. Is that a good thing or a bad thing?
Oh, that could be, that I feel like that could
It's
be
a
even.
blessing and a curse in some ways.
Say again?
Couldn't it be a blessing and or a curse?
Okay, so what's the blessing part?
Well,
It's easier to port, but that could mean like at the same time, if it's easy to port, there might be issues that aren't seen right away. Like it should port the same, but maybe there's an issue
That could be
can't foresee.
true.
it's slow.
It's slower. That's the big thing that we usually think of with interpretation versus compilation is speed.
Higher level languages tend to have that issue.
Yeah, because, well, even a higher level language that's compiled down to ones and zeros, it's still ones and zeros being executed directly by the logic, the transistors, and the flip-flops and so on inside the CPU. But here we have a whole program running in the CPU that says, okay, give me the next instruction. What does this mean? Oh, it says I should add 1 to this variable. Tell me the current value of that variable. Okay, I'll add 1. Here's a new value. Remember that for me, right? It's all these steps that are being done to interpret the bytecode.
I feel like it's a bit more secure because when you distribute it, people can't see your source.
Well, security is one of the arguments that was used in favor of Java, although it's pretty easy to reverse engineer the class files because it's a standardized bytecode, right? It's all compiling down to the same target. You can't get back comments and variable names in some cases, but to get back the general gist of what's going on is not too bad. But the security aspect comes from the fact that this thing can run in basically a sandbox, right? Your program does not have direct access to, it doesn't have direct control over what the CPU does. It can only get things to happen in your machine if the JVM decides to allow it. And so there's some measure of added security there perhaps, because you can sandbox this thing with the JVM.
You can choose access.
So is C compiled or interpreted?
I'm sold.
That's kind of
Either.
Could be interpreted, could be compiled.
what are you running on?
Typically it's compiled. When you say GCC, you're compiling, but making a C interpreter is a fine thing to do. And it can actually give you lots of options for debugging and things like that. What about when you get down to assembly language? Is that compiled or interpreted?
Like if you're
Depends whether
interpreting
you're
at that point,
magnifying glasses.
Yeah.
I feel like at that point, if you're interpreting, you're just running another, like, whatever you call it, a ghost operating system. on your
Yeah,
computer.
it's like a virtual.
Yeah, you're running a virtual machine
Yeah.
at that point, so that's
What about machine code, like ones and zeros?
that might be easier to interpret than whatever compiled code.
Yeah. I mean, that's why Java's compiled into bytecode before it's interpreted, because it lets you strip away the variable names and the comments and the formatting and get down to sort of the bare essentials. But there are some systems where the actual ones and zeros are actually interpreted. So there's a concept from the 50s called microcoding, and the idea on a microcoded machine is that the CPU itself has a smaller CPU inside, which is running a very simple program that interprets how ones and zeros should affect the environment. And so it reads in a bunch of ones and zeros and it says this is an increment location 2 instruction, and so it sends a 2 to the memory controller, and it sends a read request to the memory controller, and it reads that value and it adds 1 to it and it writes it back and so on. So it's almost a philosophical question at some point.
Mm.
All right, so Java is interpreted. Sorry?
Kind of going to Inception there.
Yeah, totally.
Is there another computer inside that?
Yes.
computer?
Yeah, and at the bottom is like the universe, I think, but that's another story. All right, so the first thing that you mentioned, object-oriented, that's the one that we haven't talked about yet, and that's going to take us basically 10 weeks to talk about. But that's probably the largest difference between Java and C, right? Is that it's got this thing called objects.
Well, doesn't that make it like way more useful?
In
many
most
cases?
aspects, yes. But it's going to make it a whole lot more fun to work with. It's going to support code reuse to a phenomenal level, which means that if we want to create a GUI that has some buttons and some pop-ups and some text windows and we can type and there's a scroll bar on the side, right? It's going to take us like, I don't know, 10 or 12 lines of code to make all that happen.
Isn't that what Zenity was?
Because, yeah, so like Zenity ++, right? Because all the hard work for doing these things has already been written for us and they're available as these classes, things we can use to create objects. And we get to concentrate on the parts of the program that we want to author, right? We want the user to type in this information, we want to respond to it in a certain way, and we can push a lot of the details aside because they've already been done for us. And an object-oriented language like Java makes it really natural to reuse these big chunks of code that have already been created and documented and made available for us. So it's going to feel very different from 222, right? 222 was very sort of down close to the metal, ones and zeros, memory locations. Oops, I hit a bad location, seg fault, right? Not going to be the case in 223. Okay, so it's going to, usually people find it to be really fun. And I think Java's a really fun environment to work in. All right, so that's our time for today. So tomorrow we'll start talking about Java as a language, and we'll go from there.